Hello everyone, now we are going to see about the causes of the Down syndrome. The causes of Down syndrome is that 95% of the time it is because of meiotic non-disjunction. What do we mean by meiotic non-disjunction? So if we see the males, they have 23 set of chromosomes, right? So this is 1, this is 2, this is 3. So this is the first chromosome, this is the second chromosome, and we have 23. So let's focus on what we want. So this is the 21st chromosome, and in females they also have a 23 set of chromosomes, and similarly we have 1, 2 and the 21st chromosome. So what do we mean by meiotic non-disjunction? During meiosis, the chromosomes have to separate into half, and so that it forms a zygote. So how does it happen? So this will have half of the chromosomes will be split. So we will have one half, and again here we will be having the other half. So this 21st chromosome in the females, instead of undergoing disjunction, it is supposed to separate. They do not disjunct. Instead they are non-disjuncted. So they will stay as such. So what happens in males? We have one half of it. So the first chromosome is half of it, second is half of it, and even the 21st chromosome is half of it. But in females we have the half set in all the chromosomes, but only in 21 we have the entire 21 chromosome, because it has failed to separate, and this will lead to, so here if you see the 21st chromosome alone, there are 3, and therefore this is known as trisomy 21 or the Down syndrome. This is that which happens 95% of the time, and the most common reason for this is maternal old age. So this is the most common cause for Down syndrome. But what about the robertsonian translocation? Robertsonian translocation is a different concept. In robertsonian translocation, the females will be carriers. They will be balanced carriers. In what sense? So they will be having the first chromosome, the second chromosome will all be normal, but the 14th and the 21st chromosome alone will be together. So the 14th chromosome, instead of being in this way, and the 21st instead of being in this way, they fuse such that they are like this. So they will lose the short arm. Here they are supposed to have the short P arm, right? So the P arm is lost, and they have only the long Q arm, which is fused one. So in robertsonian translocation, it is not present as this, and it is not present in this way, but instead it is fused together and it is presenting in this. The long arm of 14 and the long arm of 21 are attached together. So they don't have the short 14 and they don't have the short 21 arms. They don't have that P arm, it is lost. But the P arm is not much important. All the genetic information is present in the Q arm. So all that which is almost needed. So therefore the not much symptom is shown obviously in females who are robertsonian translocation. Now we have the issue only when females who have the robertsonian translocation conceive. So let's see what happens. So in robertsonian translocation, females, so instead of the 14 and 21 separately, they have 14 as well as 21. But what about the other half of the chromosome? So they have 121 and they have one half of the 14. So let this be 14 and let this be 21. This is how the females present with. So they will be they don't have another 14 attached to it, and they don't have another 21 which is attached to it. But instead one half of 14 and one half of 21 are attached to each other, and even though the chromosomally it is abnormal, they are a balanced carrier. That is, nothing is shown because all the information that is needed is present in this configuration. Now what happens when they conceive? When they conceive, there are 4 possibilities that can happen. Say this one half of the chromosome is supposed to be presented, is supposed to be split, right. So, this can have 114 and this can have 121, or it can split in this way. Instead of the normal 14 and 21, this abnormal 14 and 21 is split, and it is present in one gamete. Otherwise, it can split in this way. This 114 and this can be present. So, this is 114 and this is 14 and 21. So, this is 14 and this is 14 and 21, just like this. Or else we can have these two. So, which will be like 21 and then here 21, and this is the 14 as well as 21. So, this is how the gametes will carry. So, these are the possibilities. So, these are the possibilities that can happen. Now, when this fuses with the unaffected male, so how is the male presenting with? The males have, so this is the chromosome 14 and this is the chromosome 21. So, they will be, when they form zygote, it can be, so it can be either 114 and 121, that is all, 114 and 121. Okay. So, this is a possibility. Now, what happens in the fetus? So, if the fetus inherits this, that is a possibility number 1. That is, they will be having 214 and 221, they will be normal, that is, they will not be balanced carrier, nothing, they will be perfectly normal. But if they inherit this, that is 114 and 121, along with 114 and 21, they will again be a balanced carrier, robertsonian translocation. This is the robertsonian translocation and this is the balanced carrier. So, they will be exactly like the mother. So, they will be having 114, 121 along with the fused 14 and 21. So, this is perfectly normal. So, they will not be showing any symptoms phenotypically. But when this possibility number 3, where there is already 221 and that fuses with this, then in that case we have 114, we have 121, and in addition to it there is 121 of the mother and this fused 14 as well as 21. So, finally, there will be 321. Therefore, it will result in trisomy 21. So, this is what happens in the robertsonian translocation. I think I have made it clear to you. I hope this helps. So, and the last one is that 4% of the chances due to robertsonian translocation. The final 1% is due to mosaicism, which is also known as post-fertilization meiotic error. That means the fertilization has happened, the zygote has. So, all this is happening before fertilization, that is at the gamete level. But 1% is due to mosaicism, where the fertilization has happened and the zygote is formed. Following the zygote, there should be mitosis is happening, so that the cells are all proliferating and the cells and the organs are all formed. During that stage, that is post-fertilization meiotic error, will result in mosaicism. So, they will not be very severe, they will not be having all the severe, they will not be presenting with very severe down, because not all the cells will be containing this trisomy 21. It is only mosaicism. Here and there will be trisomy 21 will be presenting. So, they will be much severe compared to the other two. Hope this helps to you. Thank you.